two-digit divisors. Up until now, all of the division problems that we have worked with have had a single-digit divisor. This video is going to teach you some strategies to use when your divisor is a double-digit number. So let's pretend that we have this problem happening. 25 students need to raise some money for a field trip, and so they hold a fundraiser. And at the end of their fundraiser, they have earned $650, and their teacher told them that they could split the money evenly to go towards their field trip. So we need to figure out how much does each student earn at the fundraiser. So we're going to divide 650 by 25. Remember, this is the amount we're starting with, and in this case, it's the number of groups we're going to break the money into. So when we have a two-digit divisor, we're going to divide as normal by asking how many times the divisor, the whole divisor, goes into the digits of your quotient. Really, you're not doing anything different except for thinking about this as a whole number as you break it into, go into the parts of the dividend. So I made a mistake. Right here, this should have said how many times the divisor goes into the digit of your dividend, inside dividend. Sorry about that. Alright, now, how many times does 25 go into 6? Well, how many times does 25 go into 6, first of all? And we should consider using a placeholder 0 to keep digits in line. You really need to make sure you're putting the digits above the numbers you're dividing into. So 25 can't go into 6. That's why I always like to put a 0 there to remind myself to scoot over to the next number. Now I think about how many times can 25 go into 65. Well, 25 times 1 is 25, 25 times 2 is 50, 25 times 3 is 75. That's too much, so I'm going to go back to 2. And then I just multiply like normal. 2 times 25 would make 50. 65 minus 50 is 15. Then just like before, I'm going to bring down a 0. And then I'm going to ask myself how many times 25 will go into 150. Well, there are 4 25s in 100 because I know about $1 and quarters, and then the next would be 125 and then 150. That would be 6 times altogether. Then I'm going to do 6 times 25, and we sort of just figured out that that was going to be 150 by thinking about it like money. 6 quarters would be $1.50, and I would have none left over. So in the context of our story, that means that each student would get $26 towards their field trip. So I'm going to teach you a couple of strategies to help you figure out how many times the divisor goes into whatever part of the dividend that you're looking at. That seems to be the hardest part of two-digit divisors. So watch all the strategies and then pick the one that you like the best or you think in each case might help you the most. So this strategy we're going to call 159. Let's pretend that a company has to ship an item, a mysterious product, that in the boxes that they ship it in can hold 63 of the item. A store orders 895 of those items, so the company needs to ship them 895 in boxes of 63. The question is, how many boxes are needed altogether? So one thing that you might do is list the multiples before you begin. Write the first, fifth, and ninth multiples of your divisor. And then we're going to use this as a guide and go higher or lower as needed. So as you can see here, I've listed the first, fifth, and ninth multiple of 63. 1 times 63 is 63. 5 times 63 I did right here and got 315. 9 times 63, I got 567. So now, as I go through and try to think about how many times can 63 go into parts of that dividend, I'm going to compare it to these numbers and think about, do I need to go higher or lower than what I have already figured out? So looking at this, 63 can't go into 8, so I'm going to put a 0. 63 into 89, well, I know 63 times 2 would be over 120 because 60 times 2 is 120. So 63 must only go into 89 one time. 1 times 63 is 63. When I subtract, I get 26. and then I'm going to bring down my 5. Now I'm at that tricky point where I have to say, how many times does 63 go into 265? Well, let's look at the guide that we made before we even started. I immediately go here, and I see that it's going to be less than this. It's going to be possibly 4 times 63. That would be the next thing that I would try, because 265 isn't too far from 315. I know I need a number less than 315. So I'm going to try 4 times 63 and see what I get. Put the 63 on top, your bigger number on top. 4 times 3 is 12, 6 times 4 is 24, plus 1 is 25. Oh, that's perfect. That's lower than this number. Remember, you have to find the multiple that gets as close as possible to this without going over. 252 is nice and close. So I know that 63 goes into 265 4 times, and I don't have to do it again. I already did 4 times 63 here. I can just write this product over here. 252, subtract. Now, this means in our story that the shipping company is going to need 14 boxes of 63, but then we have this remainder of 13. And what that tells me is that they're actually going to need one more box because they have 13 left over. You can't just not send them. So they're going to have one more box that's not completely full. Next, we're going to use the zeros trick as a strategy for figuring out how many times the divisor can go into the dividend. Let's say that your teacher assigned you a book that was 594 pages long, and she said, let's read 79 pages a night. And you want to figure out, well, how many nights is that going to actually take me to finish? So we're doing 594 divided by 79. And when you do the zeros trick, the first thing you're going to do is round the divisor to the nearest 10 if you have a 2-digit number. So 79 rounded to the tens place is 80. Then I'm going to use the zeros trick with your rounded number to estimate. So it's always a good place to start to think about your number times 5. That's sort of in the middle. So I did, when I got the 80, I thought about 80 times 5. And remember, you can do this problem in your head because you know 8 times 5 is 40, and then you would add 1 0. Well, that's not high enough yet. I need to go bigger. So now I'm going to think 8 times 6. 6 times 8 is 48. Add another 0. That's 480. I'm getting closer, but I'm not up to 594 yet. 8 times 7, remember 5, 6, 7, 8, 56 is 7 times 8. Add a 0. Ooh, that looks really close. And just to be sure, I might think about the next number. Remember, all this you could do in your head. You don't have to write it. I wrote it so you could see what I was doing better. 8 times 8 fell on the floor. Pick it up, it's 64. Add a 0, I get 640. 640 is over this amount, so that tells me that 8 is too many. So I'm going to go back to, remember that was over, so I'm going to go back to 8 times 7. And then I'm going to find the exact amount, because remember here I was working with rounded amounts. So I went ahead and did my divisor times 7 and got 553. And I'm going to check that that makes sense by seeing when I subtract if I get something, if I get a difference down here that's smaller than my divisor, I know I'm good. So I'll show you what I mean. So I decided I'm going to go with 7. So remember, 79 can't go into 5, 79 can't go into 59, but 79 can go into 594, and we think it's going to go in 7 times. And then I found out right here that 7 times 79 is 553. Then I'm going to subtract, and I get a difference of 41. If this number is smaller than my divisor, I know that I got it. I know that I probably got it right. If you ended up with the number here bigger than your divisor or even equal to your divisor, you would need to increase your quotient up top. So thinking about our story, this would mean that it would be 7 remainder 41. That would tell me I would have 7 days of full reading of 79 pages, and then I would have 41 pages left over I hadn't read yet. So on the 8th day, I would probably have to read those 41 pages. Next, a math strategy that is always excellent is to think money. Let's pretend that Mr. E bought a big old bucket of jumbo beads, and there were 7,843 beads. I don't know who counted them, maybe Mr. E, probably not though. And there were 23 students in that class, and you had to make some projects with it, and you needed to know how many beads per student, how many beads each one could get if they shared them evenly. So we're going to think about money. If your divisor, is your divisor close to the amounts of money that we know with quarters, 25, 50, or 75? If it is, then you can use the multiples of these numbers to help you estimate. And I've written them here, 25, 50, 75, and 100, and so on. 50, 100, 150, 200. And then one that you may not have memorized, but it's really helpful to have memorized, the multiples of 75, to begin thinking about those routinely. 75, 150, 225, 300, and so on. So I hope you're realizing that 23 is really close to 25. So we're going to think about the multiples of 25 as we do this problem. So if I think about 25, 50, 75, ooh, 75 is really close to 78. So I'm going to assume that 23 can go into 78 3 times. Then I'm going to do 23 times 3 and get 69. Then go ahead and subtract. That would give us a 9 left over. Then bringing down the 4. Now I want to think about, again, multiples of 25. 25, 50, 75, 100. So I'm thinking maybe we can possibly get close to 4. Let's see if 4 works. 23, because we know 69 is pretty low. Let's try 4 or see if it's going to be over. 12. That would be 9. Ooh, it's less than this number. Hasn't gone over, so we're doing good. That'll be the quotient up there. Will be 4. 4 times 23, we just found out, was 92. And then subtract, bring down the 3. Oh, an easy one. 23 goes into 23 one time. 1 times 23 is 23, and there are none left over. So each person gets exactly 341 beads in this case.